Okay, so for anybody that just punched in, just dialed in, welcome to MAT130 again. And we're going to be doing a little bit of review, some items that we talked about in the last class, then we'll map out the new territory for today. What we're going to get into today is going to be subsets, proper subsets, and universal space. And we'll have time to introduce those ideas and get into some examples and exercises using them. And I'm going to start at the bottom here. So I've got Victoria. Victoria, when we were talking about elements of a set, if somebody tells you that there's this number 4 and it's an element of some set, what are they trying to tell us?
You mean the equal sets and the equivalent sets?
No, if we're just thinking, well, since you brought up equal and equivalent, we'll start with that.
Okay.
But somebody says equal and equivalent, we'll do equivalent set. What does it mean if two sets are equivalent sets?
Two sets are equivalent if they have the same share of the same number of elements.
Excellent. Okay, well done. Now, she said the word element. So, Tahana, what's an element of a set? Like if somebody says 4 is an element of the set B, what are they trying to tell us? And, oh, okay, I hear you. You're coming through now.
Wait, what's the question again?
Sure. Question is, if somebody were to say an element of a set, like there's this number 5 and 5 is an element in a set, what are they trying to tell you about element when they say that word? Anybody want to help Tahana out? What comes to your mind when you think element of, Tahana?
Like it goes to the same numbers.
Okay, it does go to something. It means it goes into a set. So somebody says there's the number 5 and it's an element of a set. Element is just a really fancy word for what? It means you're a member of the set. I'm going to go to the next person on the list. Looks like this is Jacob, and somebody trying to get into the room. I'm going to admit them. Okay, if I'm not saying your name right, please help me out too. Jacob, when we're talking about, we said equivalent sets before. What's an equal set? Like if two sets are equal, what would have to happen? And Jacob, can you hear us? Okay, so I have to come back to Jacob. And that brings me to Camila. Camila, I know Camila's out there. She just put something in the chat window. Camila, when we have two different sets, what has to happen to make them equal sets? I'm not hearing from Camila either. So this is for anybody that wants to answer. What has to happen to make two sets equal?
Same number of elements.
Okay, so that's definitely one. You have to have the same number of elements, exactly correct. What else has to happen on top of that?
They have to be the same elements.
Exactly correct. Well done. Perfect. Same number of elements and the same elements. So is it easier to be an equivalent set or is it easier to be an equal set? Halen, what do you think?
Equivalent?
Exactly correct. You are right. Because all you have to do is make the numbers of the set equal and then you're done. You don't have to do any other work. Right on the money. Okay, so next question is going to go to Liseth. Now, Lisette, if somebody says cardinality, and we know they're not talking about birds because they mean set theory, what do they mean by cardinality?
Excuse me, can you repeat the question? Sorry.
If somebody's talking about a set and they say the word cardinality, what are they trying to talk about? What are they counting?
The number of elements in a finite set.
Bull's eye, well done. Okay, that's exactly correct.
Thank you.
How many elements are in the set? And let's see, I'm going to skip up here to Keenan. So Keenan, if we are talking about a finite set, what would be a finite set?
It's a set that has a finite number of elements.
You said finite?
Yeah, finite.
Perfect.
I'm sorry, it has a finite set of elements. Yes.
That's exactly what it is. Yeah, a finite specific amount. Perfect answer. And Kevin's going to be next. So Kevin, if finite is a specific number of elements in a set, what would be an infinite set?
Is it a set that doesn't have real values?
Kind of close. I like how you're thinking in terms of what it can't be. That's going to help you a lot. So if we think there's two kinds of set sizes, finite and infinite, what's the easiest way to say what an infinite set is? It must be a set that's not
Finite.
exactly correct. Yeah, that's all you have to do. In the textbook, there's this really elaborate definition of a infinite set. I don't really test that, but you're going to read about it. And they're going to give you this funny thing. They're going to say a set is infinite if you can put it into one-to-one correspondence with a proper subset of itself. For you guys, I just need you to know that an infinite set would not be a finite set. And that should be more than good enough for our purposes. Okay, so what we're going to do is shift into some exercises on the screen here. Everybody feel pretty good so far about everything we mentioned already? Any questions on anything? Okay, I don't see anybody else trying to click into the session, so I'm going to go and turn over the screen here. Perfect. I need to move this chat window. Okay, you all should be able to see the big globe or the big planet, right?
Yes.
Okay, excellent. So that's not where we're going to start, but that helps me find the screen real fast. Okay, now the last time we were here, we started doing a whole bunch of exercises of using all these terms and definitions and concepts. And we began with the screen that we're seeing now, identify if you're well-defined or not well-defined. What I did just to help us reacquaint a little bit is I changed the examples that were on the slide so we can go through that and then slide into the next topic we have. I mean, the next set of examples. And we are up to, let's see, we just heard from Kevin, so Jacques is going to be next. And Jacques, if we have set A, and we just say set A is going to be letters of the alphabet, well-defined or not well-defined?
Well-defined?
Okay, you are correct. So well-defined, you just have to know exactly what's in the set, and it has to be very black and white, very crystal clear. So A is just saying, if you're a letter of the alphabet, you're in the set. That's all you have to do to be in the set. Okay, let's go to the next. That's going to be Richard. And Richard, when we see that bar, oh, I see somebody else that's trying to get into the session. Let me see if I can admit them. Okay, and now I'm going to flip back on our screen here. Okay, Richard, if we see that X bar thing, X bar X, what's the bar number mean? Sorry, Richard, can't hear you. Okay, I'm not hearing from Richard. How about Camila?
Not well defined.
Camila, can't hear you.
Not well defined.
No, it's not well defined. It's something else. Oh, you mean the answer?
Yeah.
Okay, what does the bar mean before we get to the answer? When it says like the X with the vertical line, then X, what's that bar mean? Anybody want to give that one a shout out?
Such that.
Beautiful. Okay, you're saying X such that X is an even number, which means you're in the set as long as you're even. And I think that was Camila saying she thought it was well defined. Is that what you had said, Camila? Your voice came in really low.
Yeah.
All right, Camila is exactly correct. That would be well defined. And let's see, gotta click here now. And this is gonna bring us to Max. So Max, what about this next one? Well defined or not? This one's a little funky looking.
Yeah.
You're correct. You're a good guesser, Matt. What it's saying is we've got how many elements in the set? It's a little tricky. There's 3 elements in the set. All it's saying is to get the first element, what do you have to do?
Add 2 plus 2.
Bingo. Yeah. So the set is basically 3 elements. The elements 4, 5, and 6. So that would make it a well-defined. And by the way, I'm going to try to go nice and slow because I know you guys are writing this stuff down at the same time, and these are very similar to what your test questions are going to look like. So if you don't hear an answer, you need a shout out again, just let me know. I'll be happy to go back if we need to. Okay, and Eric is next. Eric, what do we think? Well-defined or not well-defined?
Not well defined.
Okay, what do we think, everyone? Well-defined or not well-defined? We think Eric's right or wrong?
Hopefully I'm right.
Eric says, I hope I'm right. I see some people shaking their heads. This one is well-defined. What makes it well-defined? You can be in the set as long as you meet what criteria?
You're smaller than -50.
Yeah, you just have to be less than -50, and then we say you are in the set. Make sense, Eric?
Yes, it does.
Very good. And Sophia's next. Looks like Sophia starts us on the next page. So we're going to be doing with each set, are you finite or are you infinite? There's somebody else that's trying to get into this section real quick. Let me see if I can get them in and get right back. Okay, that works. Good. So we've got 2, 4, 6, and then on and out. Sophia, we think it's finite or infinite?
Finite.
Perfect. Okay, Shane is next. Shane, here's yours.
Finite.
Perfect. Finite is next. This brings us to Ashley.
Infinite.
Okay, what was your giveaway, Ashley?
Yeah, it was just a guess.
Well, you're a good guesser. You should guess a lot. What's the giveaway, everyone? How do we know that this one is an infinite set?
The dots are at the end.
Yeah. The ellipsis lets us know that after 3/4, the fractions are just going and going and going forever. And Caroline is going to have the next one. Caroline, what do we think?
Infinite.
You are correct for the same reason as the last one. Everybody feeling pretty good about going back and forth between finite and infinite. Okay, so I'm going to bring us to the next place then. And this one is that funky such that notation again. And this is Jacob.
Not finite.
Okay, good answer. It's infinite because all you have to do is be less than 0. But can you have an infinite number of negatives, Jacob?
Yes.
Oh, yeah, you're right. You could go like -10 billion, trillion, zillion, million, and you can just go forever. Negatives, you'll be an infinite set. Anybody have any questions so far on any of them that we've done? Okay, let's keep going then. And next person is Camila. Camila, you got the next one.
Finite.
Correct. Yeah, X is stuck between those values. X has to be greater than 0. Well, how much greater? It just has to stay less than 99. That would definitely make it a finite set. Okay, now what about when we change the inequality to equality signs? Now what happens? Is that going to change it to an infinite set or stay it at finite? And I think we have Halen's next on the list. Halen, is it still infinite or is it, I mean, is it still finite or is it going to go to infinite?
I'm not too sure, to be honest, but I'm gonna say it's infinite.
When we're looking at the symbols, it's saying X has to be less than or equal to 99 on the high side. And then on the low side, it cannot go below 0. So it has to stay in between 0 and 99.
Oh, so it's finite?
Beautiful. Well done. You got it in one shot.
Okay.
Finite. Okay. And then, well, the last one here. X such that X is a bright star. We'll put this up to Lizeth.
Is it the last one? I can't see it.
Yeah. It says X such that X is a bright star.
It's finite.
What do we think? Finite or infinite? How many stars are there out there?
Oh, well, then it's infinite because you can't have a specific pinpoint of
Right on.
the amount of stars then?
You would make a good astronomer. You're exactly correct. That would be an infinite set. Okay, I think this is about the last exercises for this sheet. We're going to go through a couple more to make sure we got it really good, because you're going to see a lot of these on the test. So it makes it really helpful to practice them. And when we get to our practical application next week of set theory, the better we know how to work with the terms and the concepts, the higher we're going to fly. Questions so far? I don't see anything coming in on the chat window, so I'm going to keep on going. I'm just going to double check the chat. The screen is going to, yeah, we look okay. I thought the screen was going to blink for a minute. Get back to where we were here. Okay. So the next set of exercises is going to bring us to Keenan. And all it says, Keenan, is find n of a for each set. What does n of a mean, Keenan?
I'm gonna take an educated guess.
Okay. What's your educated guess?
Well, A represents
A would be set A, so it's something of set A that it wants.
A represents the set.
Anybody want to help Keenan out?
I'm not sure. It's a tough one.
Okay, this one actually is a very commonly missed one on the exam. N stands for something really specific, but if you forget it, you're going to miss about 4 questions on the test, because it does show up in like a bunch of questions. They're going to give you different sets, and they're going to keep asking what's
Is it a null set?
No, it's not a null set, but
Is it how many elements are in the set?
there it is. Yep. How many elements are in the set? So what do we call that? What's our word for it?
Cardinality?
It is, yes. It's saying cardinality. All it wants you to do is count up the number of elements in a set. And it's really going to help to save our butt later on, because we're going to do something that involves taking a set and breaking it into smaller sets. And if you remember that one thing, that N of A means cardinality, it makes your life so easy. But if you forget that, it turns into this question that you just can't solve, and you spend all day working on it. And we'll see that later on show up. So our first is, this is our set A here, and we have Jacques that's next. Jacques, what's our cardinality?
I don't know.
So we know cardinality is how many elements are in there, and elements is like a member of a set. So how many things are in that set?
5?
Exactly correct. Yep. You would say n of a equals 5, and then you're done.
Okay.
All right. Richard is next up. Richard, you have this one.
Infinite?
Well, it's not an infinite set because it looks like it's all the even numbers between 2 and 1,000. So now we just have to figure out how many numbers are there in between 2 and 1,000.
500?
You got it.
Okay.
Perfect. Okay. Max, what's our cardinality here going to be?
$26.
Perfect. 26 it is. And Eric is next.
Um,
And the secret in this one is to look at the numerators.
There's a.
What does it look like the numerator is starting at? What's the first numerator you spot?
One?
Yeah, exactly. How high is it going? What's the highest numerator you have?
It's going to 28.
Perfect. So how many fractions are probably stowed away in there?
That's,
What do we think, everybody?
yeah, that's, when it comes to fractions, I'm really slow on that.
Is it 28?
Yeah, it's going to be 28 because when we look at the numerators start out 1, 2, 3, 4. We have the ... and then it gets to 27 and 28. So cardinality would be 28. Okay.
So if that was 28 and then the second one was 500,
Yes.
it wouldn't, so it's not 1,000, the second one?
No, because it's taking only the even numbers. Like it's doing 2, 4, 6.
Oh, okay.
That's
Got it.
Yeah.
Got it.
Okay. And let's see. Who do we have next? This is Sophia. This one's for you.
7.
Perfect. Okay. So now we're going to be working with, when we see sets, we're going to decide we're an element or we're not an element to make this a true statement. So the first one here, Shane is up. They're saying 5, and then they're giving you the set 2, 4, 5, and 7. Do we think, Shane, it's an element or not an element of that set?
I would say it's an element.
All right, yeah. And our symbol for element is going to be that funny looking E symbol. So Shane is exactly correct. Ashley, you have the next one.
Element.
You are correct. Ashley, what would you have to do to that 8 to make it not an element? How could you change it?
I don't know.
You can make it negative, for example. That would do it.
Okay.
Okay. And brings us to Caroline. Caroline, this one's for you.
Is it not an element? Because
How did
it's
you
not
know?
like in order. Because it's not like in.
What's
It's
the
all
problem?
it's all positive.
Yeah, exactly. It's positive, and they're trying to play tricks with your eyes, basically. So the negative knocks it out. It's going to be not an element. And Victoria's next. Victoria, this is yours.
Not element?
Correct. And Tahana.
It's 9 element.
You are correct. Good job, Tahana. Jake is next. Jake, you have the fun one here. This one's all technical looking.
I'm gonna say it's an element.
You're correct. It is an element. And okay, so now what we're going to do is we're going to see different expressions, and we have to evaluate true and false. And Camila is next. So Camila, true or false statement?
Oh, true.
What do we think, everyone?
False.
Yeah, what's wrong with it is Camila, when we're looking at it, is 3 in the set. Because the expression is basically saying 3 is an element of 2, 5, 6, and 8. And there's 3 in the set, we would say not yet. So it's actually going to end up being a false statement. Okay, Halen, you have the next one.
False.
Good. List F.
It's true.
You're correct. Keenan.
It's true.
Yes, good job. And Kevin.
False.
Oh, sorry about that. How about now?
False, right?
Now it would be true because it's got basically that slash through means it's not an element of. Okay, so you kind of had a double there. And Jacques, oops, sorry about that. I hit the wrong button at the wrong time. Bring all this back. This one's Jacques.
False.
Okay, you're exactly right. It's getting at, is it equivalent or is equivalent? And then they want us to think of equivalent but not equal. And Richard.
True.
Yes. Okay, good. Okay, and I think this is the last screen of exercises. Then we're going to get into some new stuff. And the more practice we do, the more it'll help us. You guys are probably going to have a whole entire sheet of just true, false, put in this statement to make the expression correct. So when you go back over the video, it's going to help you a ton to make sure that you're prepped up and you're ready for the test. I realized that you have 24 hours to finish the test, but you want to be really fast when you get through the test sheet. You want it to be done, closed out with probably within 2 hours at the most, because I know everybody's got lots of other classes. It's not just this one. And I'm going to see if I can get this person into, there's somebody that's knocking on the door trying to get admitted. Okay, so we've got these different 3 sets, and we have to evaluate true, false expressions. Max is next on our list. So Max, what do we think? We got A, B, and C, and then this is our expression. Does it look like it's true or false?
True.
Okay, good job. Eric, this one's yours.
False.
Good job. Sophia.
True.
Oh, how about now?
False.
Yeah, good job. Shane.
Yeah. I would say that it's true.
What's the symbol for N of A? What's it trying to ask us?
If it is a cardinality.
Right. So
then no, it's false.
okay, exactly correct. It's going to be a false statement. Ashley.
True.
So we got cardinality of A equals cardinality of B. And judging by Shane, what he was saying, this would mean the same number of elements are in A as in set B. What do we think?
So yeah, that's false.
Well done. It's false. And Caroline.
False.
Good job. How about now?
True.
Yes, you're exactly correct, Caroline, I'm sorry. Okay. Anybody have any questions about any of the things that we've done so far? Everybody feel like if you had to do the test right now, you would be able to get most of these correct. Okay, what I'm going to recommend, well, we're going to go into the next topic now. What I'm going to recommend is by this evening, already go through the video again and go through some of the exercises on the homework, because we might find out we know the definitions now. And even in the classroom, we might feel really good. But what happens once you're, and it sounds funny, but it's true. What happens once you're 15 minutes out of the class already?
I forgot.
Yeah, probably by 11 o'clock, we'll forget half of what we did. What's going to happen by 3 o'clock? How much are we going to remember? Maybe like one thing. By the time you go to sleep, how much are we going to remember then? Probably nothing. But if we review it in the evening and then in the morning, it's going to help you immensely. And it's going to take you less time to recover each instance that you spend going through the notes. Okay, so what we're going to talk about now, this is going to get us into the next section in the book. It's called the universal set. And what the universal set does is it kind of gets at when you're working with a set, like somebody just throws out a set B and they say in set B you have the elements 2 and 3 and 4. What we never really talked about was where did that set come from? Like, you know, where did it originate from the get-go? And universal set is going to answer that question. It's going to give you all the potential elements that were under consideration for a set that was created. And there's specific questions that can help us answer when it comes to set theory. That's why we start to talk about it. It's going to help us immensely next week when we get into our practical exercises. In fact, we won't be able to finish most of them without knowing what the universal set is about. So let's get it down on paper. Let's see what it looks like. We're going to make a universal set up. I'm making this out of the air here. It says the universal set has the elements 5, 8, R, -7, and -10. Now to get a visual on this, who's heard of a Venn diagram before? Who can tell us what a Venn diagram is? That we had Victoria next on the list, but anyone that wants to shout out, go ahead. What do we use Venn diagrams for?
Comparing and contrast.
I heard comparing and contrast. What do you mean? I heard somebody say compare and contrast. In what way?
Differences and similarities.
Okay, so it can let you compare different things, which is really useful in analysis. So Venn diagram involves circles. So what I'm going to do is we're going to put a circle and we're going to write, I'm going to put the name of the set. We're going to make set A, and set A is going to be a set we make from the universal space. I like to think of donuts because we're here at 9 o'clock in the morning when I do the circle. Inside, we're going to put 3 elements. We're going to have 5, 3, and then R. What's also customary to do with the universal set is we're going to make a little box around it. Why do you suppose we have the box? What do you think the box can help us with? Like, we got the stuff in A that's in set A. What do you think might go in between the box and the circle? Any ideas?
Objects that are not in the set A or B.
Yeah, was that Macho shouting out?
No, it was Victoria.
Oh, okay, Victoria, you're next, right?
Yeah.
Exactly correct. It's going to be all the stuff in set A, all the stuff in the universal space that is not in set A. And I'm going to put down a label. We're going to call this U to help us remember. It's the universal space. And we're going to write down that there's 8, 10, and -7 out there. And we've got this question. Something that has to do with what we call complements. This is what we're building up to. The universal set is going to help us get into that complement concept by asking what are the elements that are in the universal space that you don't find in set A. Those are the ones we just penciled in outside of the circle. So I have the same set here. It's just showing a little bit differently. Now the answer to what is in the set A that's not in the outside we call that the complement. And you have to know what a complement is. I'm going to ask you this like 6 ways on the test. So we abbreviate complement, first of all, by writing A with an apostrophe. If somebody puts an apostrophe, that means they're trying to start talking about the complement. Now, if you Google anything about set theory, and I know you're going to Google like all the homework and probably other things too, you might see A with a superscript and then C. Some people call a complement A superscript C, just because when you write a math book, you have to make yours different than everybody else's. So sometimes when we see authors making unique symbols to differentiate themselves. So if you see A, C, and you're saying this looks like the complement, but I don't think it is because the symbol's different, you're correct, it's still a complement. So officially, we'll say A apostrophe, all the elements in U that are not in A. And in this case, it's just going to have 3 elements. It's going to have -7, 8, and 10. What we're eventually going to do is we're going to use the complement in practical problems because we're going to get a lot of information about people that have done something. Like they might say, 15 people walked into the Apple store and 3 of them bought headsets, 2 of them bought laptops. But what did all the other people do that we didn't mention that walked into the Apple store? They're getting at the complements, and you can use that for analysis. Okay, so now we know universal set, we're going to get into something called subsets. And when we think of subsets, we've got the set A, 5, 3, and R. We're going to take a subset, and when somebody says sub, what do you think of, Tahana? Tahana's next. Like if somebody says sub, would it be bigger or smaller than what you started with?
Smaller.
Okay, exactly. It's going to be something that's probably smaller than the big set we began with. So what we're doing with subsets is we're going to take set A, we're going to break it up into little kinds of sets. And it's going to start to get at how many subsets we can make out of that main set. Now, you'd be surprised how many subsets we can break A up into. First thing we're going to do is we're going to go in and we're going to write in all the sets that are made up of 2 elements. So I'm going to write down as many of the subsets as I can. I just can't duplicate subsets. Like I can't start off with, if I wrote 3 and a 5, can I make another subset that says 5, 3? The answer is no, because I would be starting to duplicate things. Can we make a smaller subset than the ones we're showing here, Jacob? What do we think? And I put Jacob on the spot there.
Wait. I'm not really sure.
Okay, so can we get smaller? The answer is yes, we can. Jacob, what would be, these all have how many elements in them?
2.
Yeah, so what would be 1 less than 2? It would be 1.
1.
Could we make elements with could we make sets with just 1 element? What do you think?
No.
We actually can't. And what it looks like is this. We can make more little subsets that just have 1 element each in them. Now, so far, it looks like we've worked this as much as we can work it. There's 1 more subset we can make, but it's a really tricky one. Anybody got any guesses on what element what other subset we can make? And a way to figure out what it might be, we started with 3 sets that had 2 elements. Then we made 3 sets that had 1 element. Can we drop down less than 1 element? What do we think? Camila's next. What do we think, Camila? Can we get to no elements somehow?
Yeah.
Camila says no. What would we call a set, Camila, that had nothing in it? We have a special name for it.
Null set?
Yes, it's called the null set. And to see why this is a subset, because this is going to look kind of funky, it'd be like saying, well, how can I have a subset that's got nothing in it? I have to move the text messenger out of my screen so I can see what just showed up here. All right, much better. Let's bring us back to where we were. Okay, so the actual definition of a subset, all you have to do to qualify as a subset is you have to be an element, you have to be a set that simply doesn't have anything in it that's not in the main set. It's kind of a wacky definition, but the way it works, we'd have to let the null set be a subset. And here's why. And this will really bend your mind a little bit. Is there anything in the null set that's not in set A? Lisette is next. Lisette, is there anything in the null set that's not in set A?
No.
You're right, because what's in the null set?
5R and 3, and
Or you're thinking way too hard
I
already.
don't think there's any.
Okay, you're right.
Yeah.
Just said
Nathan.
the exact answer. There's nothing in the null set, so that there's nothing in it. We can't say that there's something that would disqualify it from being the subset. So by definition, it's allowed as a subset. Now, if that confuses the daylights out of you guys, just remember that the null set would be a subset of anything, and then you're home free. Okay, now something that's going to help you out a ton. On the exam, I'm going to ask you guys a whole set of questions. I'm going to list you sets, and I'm going to ask you how many subsets are there. And I'm going to make one of them that'll have like 8 elements in it. And there's always somebody that's really upset taking the test, like maybe the girl in the picture. And what happens is they're in the classroom, they'll come up and they'll ask me for like 8 sheets of scrap paper. And they're going to take that set and they're going to break it up into as many different sets as they can. And they're going to have their paper covered with zillions of subsets. And the reason they're upset is they forgot that there's a really simple, easy formula we could use that'll tell us how many subsets we can have. Right up here, if we look across the screen, how many subsets do we have up there? How many subsets does it look like we have there? And I got Keenan next. Keenan, how many subsets are there so far?
It's 3.
Altogether, we've got the left from right, starting from the subset 3 to 5 and going to the null space. How many would there be altogether?
Well, 6.
Exactly correct. So here's the real easy way to find the answer. I need to move I have the images of everybody here on the screen, and sometimes it goes to a spot where I don't want it to be. I have to reset this. Okay, so if we take 2 and raise it to the power of n, that's going to immediately burp out the number of subsets that we have. We just have to remember, what's n equal to? Kevin, what's our n?
Is it total number of elements in a set?
Perfect. Yeah, it's going to be the cardinality, the total number of elements. So all we have to do is take 2, raise it to the power of n, and that's going to tell us immediately we have 8 subsets, and you'll be able to finish this question within just a few seconds. Any questions on anything so far?
How'd you get 2 to the power of 3?
I'm sorry?
How'd you get 2 to the power of 3?
Okay, that was because we just happened to know that there was a formula that says if you go 2 raised to the power of n, where n is equal to your cardinality, that will give you the number of subsets. Well, we didn't explain how to derive the formula. We just happened to know that n was the cardinality, and n in our case was equal to 3 because cardinality is total number of elements in the subset, or sorry, total number of elements in a set. You okay?
Yeah, I see now. Okay,
Right.
thank you.
Excellent. That's a really good one to practice because this is the most commonly missed question on the test. Students forget what cardinality is. Sometimes they'll remember cardinality, but they forget the symbol for it. Now, the symbol that you guys are going to see, you have to memorize the symbol because it's going to show up all over the place. If we see a C with a little line under it, that stands for subset. And later on, eventually, we're going to start to do a whole bunch of questions like we had done before with the exercises. And they're going to use that symbol in the exercises. So we've got lots of different symbols now. This is another one that is going to really facilitate our understanding of the homework exercises. I'm just going to do a last call for any questions before we go into the next topic that's about proper subsets. Okay, I don't see anything coming in on the chat window. I'm just going to double check it though. And looks like not. So we're going to go ahead into the next spot. And looks like I skipped out of where I want to be. Okay, here we go. So when we're looking at all these subsets that we just had, these that we have circled are very special. And here's why. When we think about, I'm just moving something out of the way so you can see everything that came up on the screen. Okay, we see all these sets that are circled. And then next to it, we see this other set. The other set, 3, 5, and R, that's the same thing as all the elements in the main set. It seems like all we did was duplicate everything. Now, what's going on up here is 3, 5, and R. Is that smaller than set A? And we're at Jacques. Jacques, is 3, 5, and R any smaller than set A?
No.
You're right. It's in fact the same thing. Now what's happening is 3, 5, and R is also a subset. And we would say, well, how could that be? It's not any smaller. The reason why it's also a subset is because there's nothing in the main set that's not in, there's not anything in 3, R, and 5 that's not in set A. By definition, we have to let it be a subset. Now, it's very different from the elements that are in red. What makes it different than all of the things that are circled, like all the subsets in the red box? What do they all have in common that's making them different than that subset shown in orange? Go ahead.
They're all grouped independently.
Well, it's not that they're independently. It has to do with how many elements are in all those things compared to the main set. And I might be asking this in an awkward way, so I'm just going to elaborate a little bit. Set 3, 5, and R equals the main set, but are the subsets in that red box equal to set A, or is every one of them smaller than set A?
Smaller?
Right, exactly. Now, here's why that's important for us. When we think of a subset, we would like to think it's something that's smaller than what we started with. And that's why what's in the red box has a special name. We're going to call those proper subsets. And you're going to hear proper subsets all over the place in the book. So we also have a notation, a shorthand symbol that we use to describe proper subsets. And it looks kind of like a C, but it does not have a line under it like the symbol for subset did. So our definition, our official definition for a proper subset just means we have to meet the criteria to be a subset, and then we have to make sure that we're smaller than the set we started with. So the definition is saying if all the elements that are in set B are also in set A, and set B, this should say is not equal to set A, then we say that set B is a proper subset of set A. And I know this sounds like a mouthful. All you have to remember is if you're talking about proper subsets, first you have to meet the criteria of a subset, and then second, you cannot equal the main set that you started with. And we'll do some exercises so we understand how this works a little more easily. Anybody have any questions so far on the difference between a subset and a proper subset? Mhm.
No, but I actually have to go. You're gonna post this later, right?
Always, yeah, always. You'll get a notification actually of when it's recorded and posted and ready.
All right, because I have to go.
Okay, if anybody needs to leave for any reason, you can do whatever you need to do. Just make sure that you recover the lost information. All right, and let's see here. This is just a reminder again to help us make sure that we got everything sized up really well. If you want to write that down, that'll help you a lot for the exam, because I'm going to ask you to differentiate back and forth between a proper subset and a main set here. And I'm going to just open up the chat window, and I'm going to make sure there's no questions coming in. And what I'm going to ask you guys is just a question here. Since it's about an hour through, how many people feel pretty okay, or how many people feel like they're on overload right now? Just send me a message in the chat just so I can kind of get a feeling for how we're all doing here. If you feel like, oh my gosh, like I need to take a minute to review all this stuff, just write in, I'm on overload. Or if you feel okay, just write in okay or thumbs up. If we were in the classroom, it would be really easy to see everybody, but I can't see you guys, so that's why I'm just checking in. Because people are giving me, feeling pretty good. Okay, this is good. Okay, so I'm getting a few people that they're saying we're in good shape. I don't see anything coming in negative. So here's what we'll do. Let's go and do a couple exercises to make sure we're getting this stuff down really well. And I'm gonna pull us into the next spot. Okay, so what we're gonna do is we're gonna go through some exercises, and we're gonna be comparing different subsets. And we're gonna look at them, and our job is to find out, are we a subset or not a subset of the main set? So the first one here, let's see who I had next on the list. And I'm gonna start the list from the top here. Caroline, what do we think? Would we be a subset or not a subset in this expression up here? And I think Caroline's audio might have gone down. Ashley is next.
A subset?
Okay, you're exactly right. Well done. It's a subset. And Shane's got the next one.
I would say not a subset.
You're exactly correct. What would you have to do to fix it to make it be a subset?
You would have to add an F onto the right side.
Excellent.
Right.
That's exactly correct. Now, something I can't emphasize enough, because about 8 of you are going to try to do this on the test. Read this from left to right always. So it's saying, is Monday, Wednesday, and Friday blank of Sunday, Monday, Tuesday, Wednesday, and Thursday? Some people try to go right to left, and it's going to get you all messed up. You're going to get the questions wrong. So just wanted to encourage you to read it like you would read a sentence in the book, just going left to right. And let's see, Eric is next. Eric, this one is yours.
A sub.
Excellent.
Subset.
It is. You are correct. Max is next.
It's a subset.
Perfect. Okay, we have Richard next. Richard, you got the tricky one.
Not a subset?
Okay, this one is actually a subset, and the reason why, Richard, this is the part where we say, when we see the symbol, what's the symbol standing for? Everyone, what's that our symbol for?
Don't do this.
It's not don't do this, it's something else. I know the one you're thinking of, that's a different one though. That's the one where you have the null set in between a set of parentheses or brackets. This one is standing for the null set. So Richard, when we're looking at it, is there anything in the null set that's not in the set to the right?
No.
Exactly. So that's going to make it a subset. It's a tricky one. That's why it's a good idea to come back to it a few times. And I have to gotta move some stuff out of my screen so I can see what's coming in next again here. And trying to reposition stuff. Perfect. Okay. And this one goes to Jacques. Jacques, what do we think? This is another tricky one. Oh, Jacques just told us he was leaving. Sorry. Kevin is next.
Is it not a subset?
What do we think, everyone? It's saying it's got -5, -4, and 3. And on the right side, it's saying that you're in a set as long as you do what, Kevin? What do you have to be?
Less than -50.
Oh, and actually, I'm sorry. You said not a subset, didn't you?
Yeah.
Oh, so you're right. I misheard you. You're exactly correct.
Oh, okay.
Because they're not small enough. They would have to be more negative than -50. You are correct. Okay. So what we'll do is let's stop for now because we're a little past an hour, and I feel like when you do the online classes, it's a little bit more difficult to absorb the information. So I'm going to break out of the sharing function in case anybody has questions on anything. I'm going to bring us back to the main presentation screen. We'll recap some stuff we did today. We'll talk about the practice exercises and what's going to be the plan for Thursday, because we're about halfway through the set theory chapter. And before we start to recap stuff, anybody have any questions about anything we mentioned already? Okay, the chat looks pretty clear. So we were talking about everything, not only from the last week of what are elements, equivalent sets, equal sets, finite sets, infinite sets, and cardinality that we had in the last class. In this class today, we mainly spoke about the universal set, and we found out the universal set is something that helps us find out what's in the complement of a set. So if we start with a universal set might be something like 1, 2, 3, 4, 5, and 6. And then we might make a set A out of that universal space. And A only has elements 1 and 2. And somebody might say, well, hold on, all the other stuff in the universal space that you didn't use, what happened to that? And all those other elements become what we call a complement. So we talked about how to find the complement, the symbols for it. There's 2 shorthand symbols. And then we got into what's a proper subset and what's a subset. We saw shorthand notations for all those. And we found out how to count up how many different subsets there are in any given set. And we also found out a formula. Our formula was 2 raised to the power of n. That will tell us how many subsets we have of a particular set. We just have to remember that n equals cardinality. And what we'll do is for practice exercises in your books, you already have a section that's circled in the, I think it's section 2-2. It's the very next section after the last one we did. Those exercises are already identified, so you'll be able to find them when you get into the practice set. On Thursday, we're going to start to talk about set operations. We'll review more exercises just to make sure that we're okay with subsets and proper subsets, and we'll spend most of the time on set operations. That has to do with, if I got like not just one set, but 2 or 3 sets, how do I combine them together? Like how do I add and subtract sets? And we'll spend a good amount of time. We'll probably use 2 classes working through that because it's going to be a little bit more intensive. That'll be Thursday and then Tuesday. And then it'll be time to start reviewing for the test almost. That's going to give us the last piece we need to know for the last additional topic we have coming up. So I'll stay on for a couple minutes in case anybody else has questions. And otherwise, you guys did a great job today. Participation was terrific. We'll see each other again on Thursday. Pleasure to be here with you guys today.
Have a good day, Professor.
Anybody else have any other questions? Okay, I'm going to close this out then.